For Unit 10, Day 7, we're going to be talking about the law of sines. And the law of sines allows us to find missing side lengths or angle measures based on the given information in the triangle. Before we begin talking about law of sines, we're going to be talking about how we label triangles. So if I was to call this triangle ABC, the capital letters A, B, and C are the vertices of the triangle. But they're also how we're going to refer to the angles. So it's the vertices of the triangle and also how we're going to refer to those particular angles. The lowercase letters are going to be the sides. And the sides are labeled by the angle they're across from. So for instance, if this is angle A, side A is going to be over here. For angle B, here's side B, and angle C, here's side C. Law of sines is helpful because it can be used with any triangle, not just a right triangle. And what we're going to be doing is we're going to be finding a side when we know two given angles and one given side. Or we might use it to find an angle when we know two sides and we're also given one angle. When we're doing law of sines, we want to look for the given information to be arranged in the angle-angle side pattern. And we'll always have three pieces of information that we know, either two angles in one side or two sides in one angle. So in here, the rule for the law of sines is that we are going to take the sine of the angle over its side and set that equal to the sine of the angle over its side. This formula continues on and actually says sine of C over C, but we're only picking two of them to work with at a time. So maybe we'll pick these two, or maybe we'll pick these two. So the formula has three things in it, but we only use two at a time. The A, B, and C tend to be irrelevant if the triangle that we're working with happens to be called triangle WXY. In this case, we would set up a proportion, but we would use the angle and the side across from it, the angle and the side across from it. And we could put the X in there too, depending on what it is that we know. So this is just the generic way of looking at the formula. We may want to adjust the names of the sides and angles depending on what we're given. So in question number 1, they're asking for us to find side B to the nearest tenth. And in here, I can see that side B matches up with angle B. So I've got this angle and side relationship. But when I look at side C, which is over here, I don't have angle C filled in to use that relationship. However, I can find angle C because the angles in a triangle have to add up to 180, so we know that this will be 75. So my formula for this one that I'm going to use is the sine of B over B equals the sine of C over C. And I'm going to plug in what I know. So I know that angle B is 45, side B I don't know. The sine of C, C is 75, over side C, which is 12. And from here, I'm going to cross multiply to solve. So I'm going to multiply this, and I'm going to multiply this. So I will end up with B times the sine of 75 equals 12 times the sine of 45. And again, if we're solving for B, we want to divide by sine 75. We've done this a few times in this unit already. And I'm going to get that B is equal to 12 sine 45 divided by sine 75, and I'm going to type that on my calculator. When I type that in, I end up with a big decimal. And remember, we leave that decimal unless we're told to round, which in this point we are. In this question we are, so 8.8 is my final answer. For question number 2, they're telling me that we are looking to find to the nearest tenth the length of one of the congruent sides of an isosceles triangle. So in this question, I have an isosceles triangle, and I have two congruent sides, and it says that the base is 12, and one of the vertex angles is 30. Based on what we know about an isosceles triangle, if one of the base angles is 30, so, oops, I take that back, that was my mistake, it was the vertex angle that was 30. So if we use 30 here, these two angles have to be equal, so 180 minus 30 gives me 150. Split evenly, 150 divided by 2 will give me 75. So these two angles are both 75. In this, I am asked to find one of the two congruent sides. Doesn't matter which one, they're exactly the same. Notice in this case, I do not have the sides of the triangle named. I don't know what they are because I have no vertices. So if you want, you can go through and name your triangle, or you can just go through without it. So I'm going to work on, in this particular case, this angle in this side, and this angle and this side here of 12. And that's going to be how I'm going to set up my formula. So I have the sine of C over C equals the sine of T over T. And I'm going to substitute in what I know. So this is sine 30 over 12 equals sine 75 over x. And then I'm going to cross multiply and solve. And in this case, I end up with, again, a long decimal, which I am asked to round to the nearest 10. In question number 3, they've named the triangle for us, so it's triangle RST. R is 105, angle R, side R is 12, side S is 10, and they want us to find the measure of angle S. So you can put an X on it, or if you want, you can just do angle S when you're working through this. So in this case, I'm comparing this angle and this side, the ones across from each other, and this angle and this side, the ones across from each other. In the ones that we've done so far, when I set up my proportion, I set up the sine on top and the side on the bottom, the sine of the angle over the side, sine of the angle over the side. I just want you to realize that it is totally acceptable for you to flip that around on both sides. So I could put side R over sine R equals side S over sine S. So it doesn't matter whether you put the sine or the sides on top as long as you're consistent on both sides. I've seen the formula written both ways. So I'm going to substitute in what I know. This is 12 over the sine of 105 equals 10 over the sine of x. If you're using an x, just make sure it's labeled in your picture. And then I'm going to cross multiply. So I end up getting that the sine of x equals 10 sine 105 divided by 12. So x is equal to second sine, sine inverse, 10 sine 105 divided by 12. And to the nearest degree, 54 degrees. I'm not going to do question C with you, or question 4 with you, where you're finding angle C, but I will tell you that if you find angle C, if you'd like to go back and practice this on your own, if you find the measure of angle C, it does not say to round, and the whole angle measure should be 5.2798, 42641. Question 5 deals with one of the real-world examples. It says a ship is heading into the harbor. It passes through point A and sights the lighthouse at a 10-degree angle. So that's going to be your angle of elevation. And then it moves along 5 miles, and it reaches point B, and it says that here it sees an angle of 30 degrees. they're asking how far point B is to the entrance of the harbor. So we are technically looking for this measurement that's right here. So when I go through and I start working on this particular question, I'm going to work on finding the shared side first. So in other words, my two triangles share this side, and that side is the link between the two triangles. So if I'm going to find out information for side X, which I have right here, I'm going to have to figure out Y first. So the first thing that I'm going to do is I'm going to work on the triangle that goes like this, where A is here, B is here, and I'll just put L up here for lighthouse. This is 5, this is 10, and I'm looking for this shared side right here that I've called Y. At first glance, you may think that you don't have enough information to do this, but you do. If you take a look at this angle right here, you know, is 150. It's a supplement to the 30-degree angle. And the angle at the top then, when we go back and solve, turns out to be 20 degrees because the angles in this triangle have to add up to 180. So that being said, if I go back now and take a look at what I have and what I can work with, I have this angle matching up to this side, and I have this angle matching up to this side. So I can do a setup for the law of sines here. So I'm going to do the sine of 20 over the side equals the sine of 10 over the side. And then I'm going to cross multiply and solve. So when I cross multiply, I get y is equal to 5 sine 10 divided by sine 20. And when I divide that out, I end up with a y value equal to 2.5, etc. Even though this says to round to the nearest tenth, this is not my final answer, so I should not be rounding that at all. No rounding to the last step. So now if I go back and take a look at what I have figured out that shared side. So in the other triangle that goes from B to H, I'll call the harbor, and L the lighthouse, where we know we have a 30-degree angle and a side of X that we're looking for, and now a side that's equal to 2.5385653. I'm assuming that the lighthouse is perpendicular to the ground, and I can use right triangle trig in here to go through and solve. Right triangle trig being the SOHCAHTOA. So in here, this is my adjacent and hypotenuse, so I can do the cosine of 30 equals x over, remember we are not rounding this, so I have that big number, 2.53856653 times the cosine of 30. It's probably already in your calculator, the big number, so just hit times 30, or cosine 30, and when you go through and do that, you end up with an answer for x that is 2.19, etc. It does tell me now, keep in mind we're at our final answer, it does tell me to round to the nearest tenth, so the nearest tenth here, 2.2. The next lesson is on the law of cosines. So the next video, which is for tomorrow, will be on law of cosines. And with law of cosines, you're essentially doing the same thing. You're finding missing sides and angles in your picture, but it changes based on what you're given. So you're not given the appropriate information to do law of sines, so then we fall into working with the law of cosines.